This is the Hercules graphics card, otherwise known as the HGC. It is a successor to the IBM monochrome display adapter, which offered graphical capabilities with the original IBM PC monochrome display. The original Hercules manual describes it as, the Hercules card is a high-resolution graphics card for the IBM PC monochrome display. The Hercules graphics card uses the same style IBM high-resolution monochrome character set and comes with a parallel printer interface. Now, that last sentence is the important part, because the whole object of this video is to replace this ROM with our own ROM so that we can create custom ROM character fonts for the Hercules graphics adapter. Now, you could do the same thing with the IBM monochrome display adapter if I had one, but I don't, so we'll have to work with this. One of the problems working with the Hercules graphics controller is we don't have a schematic for it, so I can't be certain that this chip is any particular pinout. So I decided to do the next best thing and look at the schematic for the IBM monochrome display adapter. Let me bring you in a little bit. What you see here is sheet 10 of 10 of the monochrome display adapter schematic, and what it shows in very coarse terms is the character generator ROM here and the 74LS166 shift register. Now this shift register right here from this output is the actual dot data that's sent to the CRT, and on the input of this ROM is the address lines from the 6845 CRT controller. The top 3 lines right here are the row address, and the subsequent 8 lines that are here are the block address, or what they call the MA, memory address. There are 2 additional address lines here that we'll talk about later. Now, we're able to look at the actual board right here, identify this 74LS166 connected to this ROM, and we're able to look at the traces on the board and the pinout in the schematic and confirm that this ROM made by Signetics is actually equivalent or compatible with the MK36000 from the IBM monochrome display adapter. What is different about this particular chip from the monochrome display adapter is that there's a single character set instead of multiple character sets. If you research the MDA and the CGA, you'll find that they use the same character generator ROM. They just have different addresses for MDA or CGA. That way IBM was able to use one component in both cards. Now, this card right here, I believe, has a software capability to install a character generator ROM, because there is a 2 kilobyte RAM chip right here, in addition to the 64 kilobytes of main dynamic RAM. So I don't want to exploit that capability because the objective of this video is to replace this character generator ROM. Now, given that this was from 1984, we're going to have a little bit of a problem interfacing to that with a new EEPROM programmer like this. This is a TL8662 Plus Universal Programmer, and it is able to interface to modern chips such as this 28C64A, which is a 64 kilobit EEPROM, or sorry, EEPROM. Now, this chip right here is equivalent to a Motorola 68764, which happens to be supported by this, which is a Needham's Electronics EMP10, circa early 90s EEPROM programmer. So with this, we are able to read the ROM chip from here, and we're able to modify our character set and put it in this chip. But when we look at this chip and compare it to the one that's in the board, you'll see it's a little bit longer. Now, the microchip 28C64A is a 28-pin chip, while the original MK36 compatible ROM is a 24-pin chip. This chip right here represents a standard pinout as we know it today. It's compatible with, say, a 2764 EEPROM or any 64 kilobit typical EEPROM from today. This one is missing a few pins and they've reassigned them. So what we're going to need to do is create a daughter board that can plug in here, which accepts the modern chip and gives us a switch, because only I believe it's about 4 kilobytes of this ROM is actually used by the glyphs, but we have 8 kilobytes. So what we're going to do is we're going to create a little switch that allows us to dynamically change our ROM font on the fly. Before we get into the board design for the daughter card, let's talk a little bit about how the data is laid out in the character generator ROM. This is a typical diagram for an 8 kilobyte section of memory broken up into 2 kilobyte areas. Each one of these 2 kilobyte pages is either blank or contains character glyph data. The lowest 2 kilobytes in the character generator ROM contain the upper half of the character glyph. And then you have a blank area that's 2 kilobytes, and then starting at the 4 kilobyte mark, you have the lower half of the glyph. That means that the data is actually interleaved 2 kilobytes apart. So we have data, blank, data, blank. That's going to influence how we design our daughter card and the addressing scheme. Here we see the same diagram where we have 2 kilobyte pages, and I've annotated that with some address lines. There are 13 address lines, A0 through A12, on a 64 kilobit EEPROM. And what we can see here is that address line 12, that controls whether we're looking at the upper 4 kilobytes or the lower 4 kilobytes of the EEPROM. The address line 11 controls whether we're looking at the upper or lower 2 kilobytes of a 4 kilobyte page. The reason why that's important has to do with the way that the 6845 CRT controller generates addresses for the Hercules video card. The lower 3 address lines are the direct outputs of row address 0, 1, and 2 from the 6845. This is similar to the IBM MDA. And then the next 8 lines are these address lines are connected directly to the data bus of the video memory. So the 6845 generates memory addresses on the MA output, which then go to video memory, and the data bus output of that, containing the actual ASCII character code for each character on the screen, is then presented to the address lines on this. So you get data in, which then converts directly to an address, which then gives you a glyph on the output. Now, there are 16 lines total in the glyph. 14 of them are used. In order to generate 16 address or 16 locations, we need 4 address lines. And you can see there's only 3 here. Now, what they did on the Hercules is they tied the 4th address line to the A12 address on the EEPROM. So you can see that when address line 12 is low, it's selecting the upper glyph, and when address line 12 is high, it's selecting the lower half of the glyph. The A11 address line, which actually determines which 2 kilobyte page is read, is tied to ground all the time in the Hercules. And what we can do is we can hijack this space inside the ROM by putting a switch on the A11 address line. So if we wanted to use the factory ROM font, we would connect the A11 line to ground, and we would only access the lower 2 halves of the 4 kilobyte pages and access the original ROM font. If we set that pin to 5 volts, we will then shift which pages the Hercules monochrome is actually addressing. So we will see the upper halves of the glyph lookup tables. And that is how we're going to be able to switch character sets on the fly and use the same sized EEPROM without any other trickery. So this is the custom daughter board that I came up with. It has a switch for selecting the stock or custom ROM font, and it has a socket for the 28C64 EEPROM. I'm not going to release the schematic for this because there is actually another solution out there. There is a company by the name of Retro Innovations that sells something very similar to this. That's a printed circuit board. It has a double wiper socket on the top, and it has machined pins on the bottom. I don't think you can beat that for $5. I really don't. Next, let's take a look at what the custom font looks like when you switch it on the fly.